This is the video for section 9.3, addition and subtraction with rational expressions, with radical expressions is what that should say. We are going to still do some of the reducing that we did in 9.2, but in order for us to add radicals together, and we'll do a little bit of multiplying them. So think about this. Think about this symbol right here as a symbol. It's a symbol that stands for a number, just like if it were an X. The square root of 2 is a symbol that stands for the number that when you multiply by itself you get 2, right? It's really the best way for us to write it, but it is a symbol. And so we can treat this, we can do the same thing that we do with variables, right? So we have 5 of these square root of 2's minus 1 of these square root of 2's. All right, so that is going to be 5 minus 1 of them, or 4 of them. Okay, so when you have a symbol, that's what you do. If it were x, 5x minus 1x would be 4x. Well, 5 square root of 2 minus 1 square root of 2 will be 4 square root of 2. Okay, you try this one. So notice that they all have the same symbol of square root of 5, so we can just add together the numbers. 3 plus 8, and then minus 14. That's going to give us negative 3. Okay, so this one is a little bit different because the radicals don't match. Right? This one is 18x squared, and this one is only 8. So we can add them together unless they're exactly the same, but we don't know whether they're exactly the same because they're not reduced. So the first thing you have to do is reduce each one of them. Reduce it just like we did in the previous section, right? So we're going to take 18 is going to be 2 times 9. And the x squared will be also coming out, right? And 8 is going to be 2 times 4, because 4 is a perfect square. So these are our perfect squares. They're going to come out of the radical in these, right? So square root of 9 is 3. The square root of x squared is x. And same goes in the other one. Square root of 4 is 2. Square root of x squared is x. And I still have a square root of 2 in both of these terms. So now what we're looking at is this, all the variables and all the symbols, right? X square root of 2, and this has an x square root of 2. So we have 3 of these x square root of 2's plus 2 of those x square root of 2's, giving us 5 of those x square root of 2's. So when you add them together and they have variables and the square root symbols, they all have to be exactly the same. They have to match in order for you to add them together. So in this one, we have to check first to see. So far they don't look like any of them are the same, but we don't know that until we simplify. So square root of 5 is already simplified, and the square root of 3 is already simplified. But the square root of 12 is not. So we would have to take 12 and make it into square root of 4 times square root of 3, right, which is 2 square root of 3. All right, so the square root of 5, there's no like terms with that one, right? I don't have anything I can add together. But the square root of 3 is in common here. So since there's not a number here, it would be a 1, right? So I have negative 1 square root of 3 plus 2 square root of 3. So if I add negative 1 and 2, that gives me 1. positive 1, right? Now, this is as far as we can go. The square root of 5 and the square root of 3 are not like terms, so I cannot add them together. This is as simplified as it's possible to be. Okay, so now we have variables and radicals again. In fact, we have variables and variables in the radicals. But you have to see whether or not they match exactly. So x square root of x, and this has an x square root of x. There's no number on the first one, so that means it's a 1. So I have 1 of them plus 7 of them gives me 8 of them. I don't like how they did that. So the same thing goes for cubes. We have to get them to match, right? So these have to be simplified. So hopefully you remember that 125 is a perfect cube and 64 is a perfect cube, right? So the cubed root of 125 is 5. There's the 5. And the cubed root of 64 is 4. So that a stays under the cubed root, right? So the cubed root of a is our symbol that's in common here. So we have 5 of them minus 4 of them, so that equals 1 of them. Okay, so that's kind of the basic behind adding and subtracting. Here's some basic ideas with multiplying. Remember we talked about the fact that if you took like the square root of 7 and squared it, that undoes the square root, right? And you just get 7. It's really easier if you think about it that way instead of always multiplying. I could say, well, it's the square root of 49, which is 7, but that's like an extra step in there to think about. If you're thinking about the square root of 7 is the number that you multiply by itself to get 7, and here you are multiplying by itself, you should get 7, right? And so that will help you a lot as you're doing these problems. Because when I take square root of 7 times square root of 7, that's going to be a 7. Okay. Oh, I'm sure it's on here, so. Square root of 7 times square root of 7, and then the square root of 7 times 14. Right? So certainly square root of 7 times square root of 7 is 7. And 7 times 14, that's 98, but now I have to reduce 98. Now, instead of just going straight for multiplying like it showed here, I could have reduced first, right? I could have looked at this is 2 times 7. 14 is 2 times 7, right? And you see that I have 2 7s in there. That means that 7 is going to come out, and the square root of 2 is going to stay under. And that's the same thing that happens when I do 98. It's going to show me 49 times 2 is 98, which gave us 7 square root of 2. So either way you want to think about it, I prefer to think about it this way. I prefer to factor before so I can see all the factors, because basically that's what I have to do. When I get that 98, now I have to go back and factor, right? And find the perfect squares that I can pull out. Now when you get to here, we're done. This is not 7 minus 7 is 0. Because this 7 is not a 7. It's 7 of the square roots of 2. Okay, so this is a constant, and this is a number with square root of 2. So they are not the same. You cannot subtract those 7s. They're not like terms. Just like you couldn't combine them if I had 7 minus 7x. Right? You can't combine them here either. All right, let's try this one. So do the same thing that you would do if you had two binomials. Remember, do the FOIL or do the box or whatever, and see if you can simplify these radicals. So pause the video and go do it. Okay, hopefully you are back and had done the multiplying. I'm just going to write it here. We have square root of 2 times square root of 2, which is 2, right? Square root of 2 times negative 4 will be negative 4 square root of 2. Positive 4 times square root of 2 will give me positive 4 square root of 2. And then 4 times negative 4 will give me negative 16. All right, so you notice that, oh, I guess it's going to show this. There we go. If you noticed, if you realized this was a sum and difference, we could have just done square root of 2 squared minus 4 squared. That's what they did here. Okay, you are always free to do it the other way. You notice that these are going to cancel because one's positive, one's negative, right? So I'm left with 2, which is my square root of 2 squared minus 16, which gives me a negative 14. So here's the interesting thing about this one is that when you have a plus and minus in the same two terms in one, with the radicals, you notice that the original problem has radicals in it, but the answer does not. And that is an important thing to remember because we call these conjugates when they are a plus and a minus of each other, right? Same number in front, same number in the back, but one's a plus and one's a minus. Those are called conjugates, and if you multiply them together, they get rid of all your radicals. All right, so here's another one. Now, is this going to be the same thing that's going to get rid of the radicals? No, it's not. It's not a plus and minus, right? They are both pluses. This is a squared. And it's not going to be just square the first one, square the second one. You have to do all the terms. You have to do this one, square root of 5 times square root of 5, which is 5. You have to do this one, which will be square root of 15. Do this one, which is another square root of 15. And then you do square root of 3 times square root of 3, which is 3, right? And see it all written out here. Okay, so this was our 5, this was our 3, and this, when we have two numbers together with radicals, we can combine them, so that becomes 2 times square root of 15. Okay, now I can add the terms, the like terms, and get 8 plus 2 square root of 15. And remember, this 2 is stuck to this 15. You cannot combine it with the 8. Okay, here's another one. I want you to pause the video and see if you can figure this out. Take note that it's a plus and minus. Hopefully you saw that when you combined, or when you multiplied them, we get square root of x squared, which is just x, because we know that x is greater than 0, right? Minus 1 squared. So that'll be x minus 1. Okay, here are some practice problems. See if you can do them. Go back and watch the section of the video if you can't figure it out, or ask next time we have class. And we'll go through them. And pause the video, do the work, come back. I'll show you all the answers. All right, here are the answers. Hope you got them. Let me know if you didn't.